So I hope everyone had fun at UB hacking. Yay. Good times. So today is, really all this week is fairly open-ended demos and examples, or examples in architecture, as I say here. So I'm going to have stuff in mind for each lecture. I'll have some backup plan of 50 minutes worth of stuff I can just kind of go through of live coding and just showing architectures of different apps. But more preferred is if you have questions, if there's something that you all want to see, especially those of you who will come in this week, even though, just a reminder, there's no lecture questions this week. So those of you who will come in even with no lecture questions, I want to cater to you. I want to show you the things that you want to see. So I'll be, as always, be in the lecture channel on Discord. So let me know what you want to see, and I'll cater towards that. Otherwise, I'm just going to kind of do my thing, which may or may not be of use to you. I think it will be, but we'll see. So with that, anybody have like open questions? Obviously, right now, homework 3 is the big thing. We got another 2 weeks to work on it, so there's a decent amount of time here. But any questions on homework 3? Right now, all of the content is out there. You can do all of homework 3 with what was presented in the last 2 weeks of lecture. So are there any questions related to homework 3? Homework 3 full walkthrough in JavaScript. Yeah, I heard you. I might get to some JavaScript today. If not, I'll get to some JavaScript by Wednesday. Because there's one big pitfall that I want to make sure I cover today. Something that's a little tricky to figure out, a little tricky to set up. But obviously no full walkthrough. Yeah, homework 3 solutions. And I'll be pretty open to ideas this week. Like, if you said homework 2 solutions, I'd probably do that. Yeah?
Would you be willing to show us the step after you set up the 101 request before you look at the frame? Like, how can you see that you're actually getting stuff?
Yes, I can. That should be able to incorporate into what I'm going to show today.
Okay.
So I'll make sure that when I get to that part, I'll explain it in more detail. If not, please ask again and be like, hey, that really didn't answer my question. Sound good? Okay. All right, so let's jump into it then. We'll start with, let me close all of these so I don't accidentally, I had to edit the video from Friday because I accidentally scrolled through code, bless you. And then in 116, I was in my homework solution in 116 as well, just happened to line up the 2 lectures I was going through homework solutions. And I was being extremely cautious. The class kept laughing at me because I was like, careful not to click any wrong thing. And they're like, why are you being this cautious? I'm like, I leave solutions today, leave me alone. So let's go to our servers. I'm going to leave my big one alone, one that has all this stuff, and go back to a very basic one, which just has this handle method. I don't even need the project outline, do I? Because there's almost nothing here. And I just want to set up the structure of how to use WebSockets in this kind of structure, or in the structure that I showed earlier. It'd be the same idea, you just put the code in a different spot. But the biggest thing, the biggest pitfall that I want to talk about is how to remember the WebSocket connections. So when you have a message over one WebSocket connection, you have to broadcast that to all WebSocket connections. So you need access to every connection from every connection. And that's a little bit tricky to set up. I don't think it's too bad, but it's stuff that you've probably never done in Python. So I want to talk about some Python specific, like how to do that. And then either today or Wednesday, time permitting, I'll show you how to do the same thing in JavaScript. Even though most of you aren't using JavaScript, I do want to show it just because it's something you'll probably come across. Well, obviously for those of you using JavaScript, it'll be useful. But it's also something you're probably going to come across in your career. I said this before, I'll say it again. Python and JavaScript have two different approaches to this TCP connection, to having multiple concurrent streams occurring at the same time. And they have two different approaches for that. And these two approaches, what do I want to say? It covers pretty much how any language and library does it. I'm sure there is a third and fourth way, but this covers the general architecture of how any library is going to use it. So you're going to see probably both of these throughout your career. So I want to show both setups. So with Python, you have your threading TCP server, and I never demoed threading TCP server, did I? Maybe we'll do that. I don't know if I want to do that right now, but we'll do that at some point this week. So you have your threading TCP server, and what this does is every time you get a connection for a new TCP connection, it's going to fire up a new thread, create a new instance of my TCP handler, or whatever you named your TCP handler. I don't even use those imports. Or whatever you named your TCP handler, which extends base request handler from the socket server library. The base request handler has a handle method. So we want to, and then that handle method is going to be called once it's created. So it creates a new myTCP handler and then calls handle and puts that on its own thread. If you don't do threading, if you just do TCP server, so you would get away with this for homeworks 1 and 2, and everything would be fine. You just have TCP server. What this does is doesn't create new threads. It just creates the new object, calls handle, and then that's the only thing your entire server is doing, is handling that one connection until that connection is closed, and then it opens up again for new connections. With threading, when you get a connection, it's going to create a separate thread and put that connection on its own thread, and then go back to listening to new connections. We need this starting with homework 3, because if we have two WebSocket connections that are both keeping the TCP connection open, we can't wait for one to close to open the other one. We need some form of concurrency, and this library makes it easy to use threading. You slap the word threading in there, and the library just does it all, handles everything for us. As usual, anything TCP related, anything concurrency related, you are allowed to use libraries for, so this is perfectly fine to use libraries for. Just use threading TCP server, and you have concurrency, you have multi-threading, all that's for free. So now every connection is running on its own thread, but those threads still do share memory. So we can share memory across these threads. This is where we have to, I don't know if you've seen this in any courses you've taken yet. I hope you have. But you have to worry about concurrent writes is the big thing, where if two threads are writing to the same spot in memory simultaneously, you could have some corruption there. So that's something we really have to worry about for this specific setup. But it is something we should keep in mind whenever we have shared memory across concurrent code. That's not immutable. So in 1.16, our solution was to make all of the data immutable, and then we don't have to worry about it. And we actually didn't share any data in memory. We shared it by passing messages through the actor system. So we got around that in 1.16 by never bringing up the chance for that problem to occur. Here we do have to at least have that in the back of our minds, that that's a possible thing that can happen. So now each one of these is going to run on its own thread with shared memory. So anything in memory, each thread can read. So what we want to do is get our WebSocket connections in a place where each thread can read that memory, read those things. So here's our I got to get rid of this first. We will do well true here. Wow, my brain just stopped there. Let me actually preserve this. So I still have the very basic server set up. I can delete all these comments. So the very first thing we do is we read from the TCP socket. Now this receive, I'm sure you figured this out by now, but receive will just hang until there's something to read. So receive, I don't know if I've gone into this thing. Oh yeah, I wouldn't have. Goodness, why can't you just know what type it is? All right, I'm not doing that. Try one. No, nope, I'm not doing this. But somewhere in there is the code for the receive method. And that's going to sit there and just wait until there's information to read, and then it's going to return. You should all be aware that homework 2, doing the buffers, you should be aware of how this thing works pretty well. And I'm just going to add comments for a lot of this with the correct symbol. This is where we would read the HTTP headers. Read the headers, buffer if needed. Get there. And buffer if needed. That's where we would do that. And now if this is a request for a WebSocket connection, let me be consistent, lowercase, do the handshake, respond with 101. So if we're in WebSockets, let me put my else down here, else handle as a regular HTTP connection, just like we have all semester. So if it is a WebSocket connection, do I want any of this? I think I can just comment all this out. We'll send something. I probably won't even run the server, to be honest. Or, no, I have to. So if it is a WebSocket connection, we're going to send the handshake, handle it just like a regular HTTP request. We're going to get the request, we're going to return a response, just like we've been doing all semester. But after we return that response, we need to go back to the socket connection. We need to go back to that connection and start reading more data. We want to call receive again and have this return when we receive a WebSocket frame. So when the client sends us the client's going to create the connection. We're going to upgrade that TCP connection to a WebSocket connection. We're going to call receive, and receive is just going to sit there. It's going to do nothing for a while. When the client finally sends a frame over this WebSocket connection, then receive's going to say, hey, I got something. It's going to return that data. And then we're going to be able to process that as a WebSocket frame. At this point, we can assume that this is a WebSocket frame because it was received over a connection that's a WebSocket connection. We want to process that WebSocket frame. I want to process that frame.
Didn't find anything matching. Want to process the frame.
What even? Siri? Piss off. Could just have Siri teach the lecture. That'd be a lot easier. Process the WebSocket frame. Send frames. Send frames as needed. Broadcast to all connections if it's a chat message. Send to the other connection for WebRTC. I got all those letters out of order. So process the frame as needed, broadcast it to all the other connections. SNED. And then go back to reading from the TCP connection. So after we process that frame, we want to read from the thing again. So the question is, how many times do we want to read from this WebSocket connection? Probably infinity, right? We want to keep doing this. If we're a WebSocket connection, we want to keep doing this. Receive some data, process the frame, send it to whoever needs this information, and then read from the socket again. We want to keep doing this forever. So this is where we use our while true. Something rare to actually have a good use for in programming, but this is a case where we actually want a while true. I mean, you don't have to set it up as a while true, but this is where we can use a while true to keep reading frames and then process those frames as they come. So we keep waiting at receive and then do the thing. When we receive returns, we're going to do our thing, and then we're going to go back to receive, get some more, get another frame, and just keep repeating this process almost forever. There's a few extra steps we have to do here. Process, parse the frame headers, up to payload, up to, how do I want to say this? Parse the WebSocket frames up to opcode. We'll do this each step of the way. If opcode is (1000), that's our opcode to close the connection. Break. So this is the only way we can exit this forever loop, is we're going to see an opcode of 1000, and then we're going to break out of the loop, which is, if you haven't seen this one, just literally the word break. That's going to exit the current loop. This will exit the current, like the current block of code for the current loop. Man, I'm wording that weird. The point is, if you have nested loops, it's only going to break out of the inner loop. It's not going to break out of every single loop. So if you haven't used this keyword before, that's what it does, is whatever innermost loop you're currently in, it's going to exit out of that loop. It's just going to end that loop very abruptly. Something you have to use with caution. It's a very powerful thing because it really does disrupt code flow in a very serious way. So it's something we use with hesitation. Be aware of the power that you have with this thing. But break is just going to end the current loop. Could be right in the middle of the loop. That's why you got to be careful. You might be halfway through processing one iteration of the loop and then just break. You might have data structures. If there's, say, 2 data structures that you're updating throughout the loop, and you update one and then break, and the other one's not updated, you could have some trouble there. So just use with caution, but this is a case where we would use break. Or you can use while opcode not equals 100, and you could set it up that way. Or if you have the opcode of 100, set a flag and say, well, this flag is true, then continue the loop. So a few different ways. Break is the easiest one to set that up. So if opcode is 1000, break. Read, parse the payload length. Buffer if needed. So there might be a case, well, inside this while true, you're going to hit another while bytes read not equal to payload length. Just like what you did for homework 2, we're doing another form of buffering. Same setup, same idea, except the content, instead of reading the content length header, you're parsing the payload length from the WebSocket frame. And you're going to read from the payload until you've read that many bytes, and then you're done reading after that. We will be checking this. We'll be checking, apparently, we found out Chrome will cap your WebSocket frames to 131,000 bytes, so we won't test over that. It's crazy the things, like once I think I am aware of every pitfall when I release a homework, and then things like that come up. Because I tested in, actually Opera had the same thing. I guess I didn't go over 131 in my testing. Yeah, I must not have. 131,000. I got up to 100,000, I know, but I must have stopped right there and said, well, 100,000, we're good. But we won't test over that because it's just not fair. Once you get over 131,000, Chrome will, and Chromium, I should say, will send 131,000 bytes with a fin bit of 0, and I say you can assume fin bit's 1, so it's not fair to test that. Firefox does not do this, so it would still be fair to test in Firefox. So if your buffering only works up to 131,000, we're going to go over to Firefox with a fin bit of 1, and it'd be hard to have buffering that works up to 131,000 and not beyond. So I don't think that'll affect anyone, but that would be fair game. No, it wouldn't, because I updated the doc. What am I saying? I updated the doc, so it's not fair game anymore. All right, so anyway, buffer if needed, and then process the frame after you're done buffering. So that's kind of the overall structure of how you're going to set up your WebSocket frame. You're going to enter this while true, whether it's in this or, and let me be careful again, I don't want to have to edit another video. Or it's in here. You can add a path. I added a WebSocket path to the router setup that I showed you regrettably before homework 1 was due. And add it to a path like that and do all this logic in that path, in this callback function. In this function, I have the same logic that I just outlined in the other server. I have that same exact logic, but it just happens to be in a different location in the code. I think I can just have hard-coded chat history, reading the WebSocket key. Yeah, this is fine. Because I do want to go back to this file. Let me make sure I'm not leaking anything. Reading that, reading the header, sending it, calling my, adding to the WebSocket connection. This is the thing I'm about to show. Generating a random username. I want this. Then hitting my well true, read the WebSocket frames. Right here. This is the other thing I want to point out. My compute accept. I have a separate method for that, so I can test it easily. If I just have that inside my code and not modularized into a separate method, it's very hard to test. I've talked about that before. There was actually a bug that I ran into that I would not have found if I wasn't doing this, at least not for a long time. But I did find very easily because I was testing like this. The base64 encoding library that I was using from Python, the method that I was using from the library was appending a new line character to the end of the base64 encoded string. Because I was using a method that was made to base64 encode an entire file, so it treated that as a single line in a file and appended a new line character to the end of it. So if that's happening to you, hopefully you have tests set up and you can just see that /n and be like, how's that /n doing there? And then call the proper method. That would have took me a long time to find out if I was firing up the server every single time. All right, so the next thing we want to do is if we are a WebSocket connection, we would generate a random username using that code that I gave. I gave this line of code in the homework document in the handout if you haven't seen that yet. So generate a random username for this user, and then I want to mark this user as a WebSocket connection. That's the part we want to talk about. So all this is like lead up to that. Let me make sure there's nothing in. Yeah, homework 2 grade. I always know, this is why I should have known it was a joke on Friday. I always know when homework grades are released because my inbox blows up with regrade requests. Which, I don't know. I'm not going to comment on that. I will respond to you all. It might take a little while, though. At the very least, I'm just going to give you more explanation of why you got the grade you did. But if there is a legit mistake, then I'll fix it. I'll remedy that. Once we have the payload parsed, what exactly do we do with it? Do we just append it to finbit, reserve, and mask 0, then convert it to bytes, and then send all to each client? Yes, but you also have to compute the payload length and write the payload length to your frame. That's the only thing you're missing there. You do have to do all that other stuff, though. Payload length, which can be a little tricky. You have to do some searching how to do that in Python. Or if there's demand, maybe I'll just show that this week. But you do have to compute the payload length, which can get a little tricky, getting every bit to be exactly what it should be, because your Python integers are going to be 32 bits. So you either got to write that into a 7-bit value, or a 16-bit value, or a 64-bit value. So that gets a little tricky to do. Actually, I think Python ints are 64-bit these days, if I'm not mistaken. But it's either 32 or 64, neither of which are necessarily what you want. So you do have to be aware of that. You have to do some bit level writing, which is, just takes knowing the right methods to write. All right, so what I want is a data structure that's going to store my WebSocket connections. I'm going to store them. How do I want to store them? So I did a list in my solution. I think I do want to do that just to be more accurate as to what I expect you to do. So a list of WebSocket connections. I could also do a dictionary, which is going to map username to the WebSocket connection. Let's just do a list, because that's going to get you through this homework just fine. But let's use a list. I'll set up both. Why not both? And I want to store this connection itself. And I want to store it in a way that other connections in other calls of the handle method in other objects of type myTCPHandler have access to be able to send bytes over this TCP connection. So how do I send bytes over a TCP connection? I'm going to do self.request.sendAll and ship those bytes, right? So in WebSocket connections, I always forget these. I think it's push, right? Push, what I want to do is push Python. Push self. I either want to push self, or you could do self.request. So you don't have to type .request every time. But at least push self, which in my paths in the server setup that I showed, when we call handle request, we're passing self, and then all throughout this code, every path that we write, it's going to get that reference, and I call it handler throughout that code. So if you're using my code, handler is the same as self when you're in that receive method, because receive, I'm passing self. I'm passing self to the handle methods, then the router forwards it to those other handle methods. So I'm just going to pass the reference. That's an object on the heap. I have a reference to it. I'm going to pass that reference around. Self is a reference to the current calling object. So self is a reference to this object of type myTCPHandler, and I want other people to have access to that handler, so I'm going to give them a reference. That reference is in self. Store that reference in a shared data structure, and then everybody's going to have it. Is this not? Oh, it's append. It's pushing. No, I'm really messing this up. Dot. Okay, there we go. So that's going to give them a reference in a shared data structure. Everybody has a reference to everybody else's handlers, because handle, new myTCPHandler, call handle, that's what the server is going to do. And then each WebSocket connection, each user is going to add their information to, in this case, these both data structures, dot of username equals self. Or we can map username to that. So if we have a setup where we want to remember everyone's username, like you have to do for your project, I would store them in a data structure that maps usernames to WebSocket connections. And I actually like to do this both ways. I'll have WS users, username to WebSocket connection, and then WebSocket connection to user. So I have an easy O of 1 lookup either way. It's a little redundant. It's double the amount of space, but it gives me O of 1 lookup. I have a WebSocket connection. I need to know the user. I have a username. I need to know the WebSocket connection. I can easily go in both directions if I have both those data structures. But at least one, so you have the information. Then you can do a little logic, a little O of N logic to go the other way if you need to. So these variables is the part you might not have seen in Python yet. I put these variables outside of all the methods in a class, in a Python class. Now, if you're coming from Java or Scala, well, all of you have seen Scala, right? Java behaves the same way. If you put variables out here, they become fields, or in 116 I call them state variables. They'll become object-level variables. So every time you create an object, each object gets new instances of these variables. Python does not do it like that. For Python, if you want variables at that level, let me just jump to my other server where I do it. You have to go into the constructor and do self.router, like something like this, self.something equals something. That's going to create an object-level variable, or an instance variable, or a field, or whatever you want to call them. This is going to create a field, and that's object level. Every object has a variable named router now, because I have this line of code. And that's how you create your fields in Python. Variables out here are class level variables, which is something we don't do in 116. We don't mess with class level variables. These are class level variables. So the myTCP handler class itself, regardless of any objects of this type, the class itself has these variables. So there's two variables that are at the class level, which means that there's only one copy of each of these variables ever. Because there's only one instance of this, there's only one class of type myTCP handler. We can have many objects of this type, but we only have one class of this type. So these are class level variables, the same as static variables in Java or object variables in Scala. When we created an object and used the keyword object in Scala instead of class, it's like putting variables in that object class, or the object class, in that object. So these variables are shared across connections. And like I did over in my other server, you might have seen it real quick. I want to do this counter. Just as a proof of concept, counter equals 0. Oh, come on. Don't want to do any of that. Counter equals 0. Counter plus equals 1. Can I do that in Python? I always forget. Oh, yeah. Yeah, I can. I can't do counter plus plus is what I can't do. My TCP handler. So whenever I want to access these variables, I specify the class. I can't just, notice how every time I forget to type the class like I just did, I'm going to get an error because there's no variable named counter. That variable named counter belongs to the class. So I have to do the class dot counter, just like if we did like math.abs. That's something that belongs to the math object, or the math class. It depends what language you're using. But it belongs to the math class. If I do I even know how to do that in Python? Math.py. It's just like accessing math.py. That's a variable that belongs to the math class. There's only one instance of the pi variable because we don't need more than that. It's a constant even. We're doing the same thing here, but with our own class and with our own class variables. So let me increment counter and then print, forgetting it again, my TCP handler.counter. Then if we do fire up this server, what port am I on? 8000. And go to 8000. Shouldn't get any response because I think I messed up my nesting. I think we're hitting that well true and never getting out. But let's do this a few times. Let's do it in another tab for good measure. And go to our server and see what we printed out. And even across multiple connections, every time I refresh, it's going to be a new TCP connection because each previous one is stuck in that while true loop. Those connections are still open. We're going to get that counter printed out each time. That's shared memory across every connection. And the same thing with these. Actually, why don't I print these out too? Let's print out this whole thing. Or we could be fancy and use the debugger. That's not. I don't wanna. Let's print this thing out. There's I was reading some documentation and figured out how to free up the port faster, but I forget how it works. I never implemented it. But there's a setting in this server that can say, once the program stops, kill all the threads too. I forget what it is. I have to start using that. But I'm just going to wait for this port. This is exciting, right? Python ints are not size restricted. Oh, yeah. I did not recall that. So if I just refresh on the same tab over and over, and a different tab for good measure, we should see all of those connections. Come on, why do we only see two? I should see more. I mean, we had multiple. We got up to like 5 on the counter last time. I'm not going to try to debug that right now. But we have our connections shared across all of our users. We have those, that counter. There we go. We got another one. And we have that counter incrementing. There they go. They're coming in. Probably because I'm in a well true and everything's really messed up and I'm never sending responses to my clients that we're getting jammed up here. But we can see that we have that data structure populated, and it is shared across all connections. Now, I talked about thread safety a little bit. I'll talk about that. Oh, I don't care. I'll talk about that a little bit here. The list class in Python. Can we get to append? Is it not in the official documentation? That sucks. But the appending to a list is actually thread safe for free. Python lists are just thread safe. So we actually don't have to worry about that if we're just using data structures like this. So we kind of get that for free. Plus the odds of 2 WebSocket connections when you're manually testing things occurring at exactly the same time is pretty low. We're manually opening up tabs. It's not like we have a script that's going to open up a whole bunch of connections. So we're pretty safe on that. All right, let's stop this, kill it. And we do get all these connections, we see that. But if we don't do threading, we're going to get a bit more jammed up. Now we can only handle 1 connection at a time. Each connection is entering a well true. So let's see what happens here. Do we need to do anything else to close the TCP connection? We should. Oh, I have this set up crappy. What we should actually be doing is this. And then once the connection's closed, it'll gracefully close everything down. Because we should be gracefully closing. It'll get rid of this address already in use stuff. It's kind of bad that I'm even showing you that kind of garbage, but this is what we should be doing to close the connection a little more gracefully. But in here, if you're asking about in this well true, if you get a 1000, all you have to do is let this method reach the end of the method. Once that stack frame closes, the socket server is going to close the TCP connection for you. You don't have to worry about that. But we do need to shut down the server gracefully, or at least we should, with this with as syntax. I didn't realize I didn't even have that on my example. All right, we're still not sending any responses, so we don't expect much to happen over here. But I'm just going to load the page on 3 tabs. And now we're only going to see one connection here. This first one is in a well true, and we're not threading anymore. So that second and third connections, we never even get to open them. The server's busy in this well true loop for one connection. It's not open to new connections. So we're only ever going to see one until eventually maybe something will crash and that one will end, and then the other ones will come in. But it's going to not work at all. Once you have one WebSocket connection in a well true, you can't allow another WebSocket connection because this is not what the server is doing. But with threading, which is why early in the semester I say don't use the socket library, use the socket server library. With the socket server library, you just slap the word threading in there, and it's like, oh yeah, you want me to use multi-threading now? Cool, I got you. Super easy. Library has it handled. If you look up TCP connections Python, you'll get a tutorial that just uses socket, which the socket server library under the hood uses the socket library. Like one of the first tutorials that shows up just says, this is how you do it with the socket library, and you have to manage your own threads or your own other solution for concurrency, however you want to handle concurrency. And that's painful. Painful in a way that's not related to the content of the course. Like I don't want this course to be hours and hours of figuring out how to, relearning concurrency and figuring out concurrency from what you learned in 220. We could, but I don't want to go down that road. int.2byte. Python insert. Oh yeah, I already read that. Not size restricted. Yeah, I forgot is that true? They're not size restricted. Do they just grow? They just take up more bytes as needed? That's neat. Magic, probably. That's pretty cool. I didn't know that. I think I did at some point. It's one of those things I keep forgetting, though. If opcode is text, will the payload just be the text converted to binary? So if the input is high in the chat box, then use an online calculator that turns high UTF-8 into binary. Will I see that result in the payload? The payload will be bytes. When the opcode is text, the 0001, which is the only other opcode you'll see. You'll either see text or closed connection. If it's text, the payload will be just bytes still, but you'll know that they're encoded using UTF-8. So you can decode that. What I want to say, you can safely decode that into UTF-8. If the opcode was binary, that's your signal to say, hey, you can't decode this using UTF-8. You got to treat it like we did our images in homework 2 and never decode that using UTF-8. For this homework, we can use decode into UTF-8 on all the messages. They're either going to be chat messages, which are JSON, or WebRTC, one of the 3 WebRTC messages, which again are JSON. So we can safely decode them as strings, or just take the bytes. Here's a trick, or not a trick, but actually no, I can't say that. But for the WebRTC messages, you don't even have to decode them. You're just taking the payload, putting it into a new WebSocket frame, and then sending it to the other client. You don't have to do anything. I almost said you could do that for all of them. It's not quite true for the chat messages because you do have to escape the HTML. So you have to decode it into a string, escape the HTML, re-encode it into bytes, and then send it over to broadcast it to all clients. Oh, and now that we have our data structure set up, I better close this up. Now that we have all our data structures set up, you say for connection in my TCP handler dot WebSocket connections, connection dot request dot send all. Oh my goodness. Siri, you can't help me. At least I have her muted this time. And then send the WebSocket frame to all the WebSocket connections. So you have access from any WebSocket connection. You have access to all WebSocket connections by passing, just a reminder, the big thing was passing self to a shared data structure, which in this case we'd use as a class level variable. These variables could also go up here if you don't want them to be class level. You could have them be module level. I don't recommend that, but you could potentially have them up here. The problem is, oh yeah, you can't even do that in certain cases. The problem is, when I say counter, which counter do I mean? So if I say counter equals, or plus equals in this case, counter equals 1. In Python, this is a syntax to create a new variable named counter and assign it the value 1. And that's what it's going to do. It's not going to update this variable. If I highlight this, my ID doesn't recognize that this is the same variable because they're not. This is declaring a new variable named counter. So I don't recommend creating package level variables. I believe there's a way to make that work, but it's a lot easier just to use class level variables because then they have defined names. My TCP handler .counter, I know what variable that is. I know what variable that is. And one last thing that I have time to talk about here is when you're using my setup and you need to use these variables across other files, we import them. We import my TCP handler. In this case, from the server.py file, we're going to import the my TCP handler class. And now I have access to that in other files. But you do have to import it if you're using those class level variables from other files. Just import it, and then you can have access to that shared memory through the class variables. Your TCP connection closes without sending the opcode 1000. Oh, and I got to mention that. When you do get the 1000, you would update these data structures as well and remove the client from those data structures. Move from data structures and break. I'd like to see that. If closing the connection without sending the opcode 1000, I mean, it should. The browser is supposed to send 1000. The connection can close if you do something wrong. Like if you send a frame that's not formatted properly, the client's going to close that connection. It's going to say, I don't know what's going on here. And it's going to close the connection. So if the connection's closed without a 1000, I would look into if you're doing something that's making that connection close from your end. So if something strange happens on your end, it's just going to close the connection. That would be my guess. That would be the first thing I'd look for. You use the global keyword, and global variables are bad. I mean, class level variables are bad enough. Global variables are the next level worse. All right, we're at 10:51 anyway. All right, so that's it. If you have things that you want to see, like next time I'll do this similar thing in JavaScript. So if there's things you want to see Wednesday and Friday, let me know one way or another. Probably on Discord would be the easiest way. See you all Wednesday.